Hello, and welcome back to another Orange Coast College Mathematics video. In this video, we're going to talk about evaluating expressions with square roots. To start off, we're going to talk about the multiplication property of radicals, which is very integral to doing all of these problems. This property states that if I can write a number underneath a square root as two numbers multiplied together, I can actually split them up as the square root of each of those numbers individually multiplied to each other. Now, in general, I want to have the number that's in the square root to be as small as possible. For example, let's go down to number 1. I have the square root of 8. Now, the square root of 8 is not a perfect square. However, there is a perfect square that divides into 8. As in, I can rewrite 8 as the square root of 4 times 2, right? Because 8 is 4 times 2. However, following this property, I can rewrite this as the square root of 4 times the square root of 2. But what is the square root of 4? The square root of 4 is 2. And so our answer is 2 times the square root of 2. Now notice, the square root of 2 can't be broken down any further. So our final answer is 2 times the square root of 2. So let's move on to our second problem, the square root of 54. Well, 54 is not a perfect square, so we think, how can we break down 54 into a perfect square times something? In this case, I think of 9 times 6. I can rewrite this as the square root of 9 times 6, and we can separate it using our property, so we get the square root of 9 times the square root of 6. But what's the square root of 9? The square root of 9 is 3. And so our final answer is 3 times the square root of 6. Moving on to our third problem, we're now looking at addition and subtraction. When adding or subtracting with square roots, we need to make sure that we have the same number underneath the square root. And so I think to myself, the square root of 2 is the smallest that it can be. I can't break it down any further. But maybe I can rewrite the other one as the square root of 2 times something. And so I say, all right, can I write 8 as 2 times something? And I can, right? We did it in number 1. This is going to be the square root of 4 times 2 plus the square root of 2. And so we can separate our 4 and 2, and this will become the square root of 4 times the square root of 2 plus the square root of 2. But what is the square root of 4? The square root of 4 is 2, and so we get 2 times the square root of 2 plus the square root of 2. So we have 2 copies of the square root of 2 and 1 copy of the square root of 2. So this is going to become 3 times the square root of 2. Moving on to our fourth problem, we have the square root of 75 minus the square root of 12. Now it's similar to the last one, as in we need to make sure that we have the same number underneath the square root, but this time both numbers can actually be broken down. So I like to start with the smaller one because it's usually easier. So I'm going to look at the square root of 12. So let's rewrite this as the square root of 75 minus, and then let's figure out how we can break down 12 into a perfect square times a number. Well, what are my perfect squares? We've got 1, 4, 9, 16. Well, 9's too big, 16's too big. 1 is the obvious one that doesn't really do anything. But 4, we can rewrite 12 as 4 times something. So let's do that. So this becomes the square root of 4 times 3. So we can separate this out, and this becomes the square root of 75 minus the square root of 4 times the square root of 3. But what's the square root of 4? The square root of 4 is 2. So this will be 2 times the square root of 3. So now I'm thinking to myself, all right, this square root of 3 can't be broken down any further. And so I want to rewrite 75 as 3 times something. Well, can I do that? Yeah. We can rewrite 75 as 3 times 25. So this becomes the square root of 25 times 3 minus 2 times the square root of 3. So this becomes the square root of 25 times the square root of 3. But what's the square root of 25? The square root of 25 is 5. So this becomes 5 times the square root of 3 minus 2 times the square root of 3. And so our final answer is 3 times the square root of 3. Moving on to our fifth problem, we have the square root of 6 times the square root of 3. And so there's two ways that we can do this. I'll show you both. So the first method is just multiplying everything out and then seeing if we can find a perfect square in the number that we get. So the square root of 6 times the square root of 3, following our property, is just going to be the square root of 6 times 3. So the square root of 6 times 3 is going to be the square root of 18. And then I think to myself, can I rewrite 18 as a perfect square times a number? Well, let's look at our perfect squares. 1 squared doesn't really matter. 2 squared is 4. Can I write 4 times something to equal 18? No. What about 3 squared? 3 squared is 9. Can I write 9 times something to equal 18? Yeah, 9 times 2. So I can rewrite this as the square root of 9 times the square root of 2. And so we get 3 times the square root of 2. Now, the other way of doing it is I can take each of these and break them down as much as I can before I multiply anything together. So let's try that. So how can I break 6 down? I can break it down into 2 times 3. So this becomes the square root of 2 times the square root of 3, and then times the square root of 3 that was already there. And then I think to myself, well, I have a square root of 3 times a square root of 3. I have the square root of 3 squared. If I have a square root squared, it'll cancel out, and we're just left with the number that's inside. So this will be equal to 3 times the square root of 2. Both methods work. It's whichever one you like best. Moving on to our last problem, let's try doing both ways. Well, we have the square root of 15 times the square root of 5. According to our property, this is just going to be the square root of 5 times 15. So, what's 5 times 15? 75. So now we have the square root of 75, and we think, how can this be broken down? 75 isn't a perfect square, so are there any perfect squares that go into it? Well, 4 does not, 9 does not, 16 does not, but 25 does. We can write 75 as 3 times 25. So we write this as the square root of 25 times 3. And hence, this becomes the square root of 25 times the square root of 3. But the square root of 25 is 5. And so that's our final answer. Now let's try it the other way, where we break this down as much as we can and then multiply things out. So how can I break down the square root of 15? I can break that down as the square root of 3 times the square root of 5. So this becomes the square root of 3 times the square root of 5 times the square root of 5 that was already there. Now what do we see? We have 2 square roots of 5 being multiplied to each other. It's the square root of 5 squared. So the square root is going to cancel out, and we're just left with the number that's underneath, which is 5. So we get 5 times the square root of 3. Now let's move on down. We have one more property that we need to discuss. It's the division property of radicals, which has a very similar flavor to our multiplication property of radicals. This just says that if we have the square root of a fraction, we can actually separate it as the square root of the numerator divided by the square root of the denominator. Now, another note about division is that the proper form for having radicals in fractions is that we don't want to have any radicals in our denominator. Okay, so with this in mind, let's move on to our next problem, number 7. So we have the square root of 5 divided by the square root of 7. Now, we can separate this using our property as the square root of 5 divided by the square root of 7. However, we have this little rule that says no radicals in our denominator. So how do I get rid of the square root in my denominator? Well, all that I have to do is multiply by the denominator divided by itself. As in, I'm going to multiply by the square root of 7 divided by the square root of 7. What am I doing? I'm multiplying by 1, right? Because anything divided by itself is 1. So I'm not actually changing the value of my answer. However, this does allow me to multiply the square root of 7 times the square root of 7, which will get rid of my radical. So this becomes the square root of 5 times the square root of 7, which is the square root of 35 divided by the square root of 7 times the square root of 7, which is just 7. Now I can't rewrite 35 as a perfect square times a number, so we'll just leave it like that, and that's our final answer. Moving on to number 8, we have the square root of 5 divided by the square root of 15. Now there's two ways of doing it. We could get rid of the radical in the denominator like how we did in number 7, or we can break apart our denominator similar to what we did in number 5 and number 6. Let's do both ways. So first off, let's just get rid of the radical in the denominator like how we did in number 7. So I'm going to multiply by the square root of 15 divided by the square root of 15. And what do we get? We get the square root of 75 divided by 15. From the previous problems, we know that the square root of 75 is going to be the square root of 25 times the square root of 3. And so we get 5 times the square root of 3 divided by 15. But what's 5 divided by 15? 1/3. So this becomes the square root of 3 divided by 3. So what's the other way of doing this? We can break apart each of these as much as we can and then see if anything cancels out. So the square root of 5 is as small as it can be, but we can break apart the 15. We can break it apart into the square root of 5 divided by the square root of 3 times the square root of 5. So we see that we have a square root of 5 in the numerator and in the denominator, so they're going to cancel out. And so we are left with 1 divided by the square root of 3. However, we still can't have a square root in the denominator, so let's multiply by the square root of 3 divided by the square root of 3, and we get the square root of 3 divided by 3, which is the same answer. Moving on to number 9, we have a slight variation, and we're going to have to introduce a new idea. In the previous problems, when I wanted to get rid of the radical on my denominator, all I had to do was multiply by the square root divided by itself. So in this case, we have square root 6 divided by square root 6. Well, if we do that, and let's just look at the denominator, what's going to happen? Square root 6 times square root 6, that's going to give us 6. So we're good there. However, this has to distribute to both pieces. So now we have 4 times the square root of 6. So what really happened, we got rid of one of the terms that has a radical, but now we've made the other one have one. So what do? Well, we introduced the idea of a conjugate. Now, what is a conjugate? The conjugate is just going to be the same numbers right here that you see, except the only difference is that you're going to change the sign. So we're going to multiply by the conjugate divided by itself. So we're going to multiply by the same numbers, right? 4 and square root 6, except instead of a plus, we're going to have a minus. So this will be 4 minus the square root of 6. And again, we're multiplying by that divided by itself. So we're still multiplying by 1. It just looks weird now. Let's go ahead and multiply this stuff out and see what we get. So we get, on the numerator, 7 times 4 is 28, and 7 times negative square root 6 is negative 7 times the square root of 6. But let's check out what happens on the denominator. When we multiply this out, we're going to have 4 times 4, which is 16, and then 4 times the negative square root 6, so minus 4 times the square root of 6. Now we have the square root of 6 times 4, so plus 4 times the square root of 6. And then we have square root 6 times negative square root 6. So this will be minus 6. So what do we see? We have a minus 4 square root 6 and a positive 4 square root 6. So these two are going to cancel each other out. And what are we left with? A number minus a number. So we've gotten rid of our radical on the denominator by multiplying by the conjugate. So now we can further simplify everything. So what do we have? We have 28 minus 7 square root 6 divided by 16 minus 6 is 10. So our final answer is 28 minus 7 times the square root of 6 divided by 10. Moving on to our last problem, we have something very similar. Now, in the previous problem, we wanted to get rid of the square root in our denominator. And what did we do? We looked at the sign in the denominator. So, in this case, we need to make sure we look at the sign in the denominator when we're choosing our conjugate. It's a plus sign in the denominator, so we're going to multiply with a minus sign. 3 minus the square root of 3 divided by 3 minus the square root of 3. Again, plus sign, minus sign. They're opposites. So, this becomes, let's do the numerator first. 3 times 3 is 9. 3 times negative square root 3 is going to be minus 3 square root 3. And then we have negative square root 3 times 3. So minus 3 square root 3. And then we have negative square root 3 times negative square root 3. The negatives are going to cancel each other out. And so we have plus 3. Now let's look at our denominator. This becomes 3 times 3 is 9. And then 3 times negative square root 3, so that'll be minus 3 square root 3. Then we have square root 3 times 3, so plus 3 square root 3. And then square root 3 times negative square root 3, so minus 3. Now again, we have a negative 3 square root 3 and a positive 3 square root 3. These two are going to cancel each other out. And so we're just left with a number minus a number in the denominator. So we've gotten rid of our square root in the denominator, which is what we wanted. So this becomes 9 plus 3 is 12, and then minus 3 times the square root of 3 minus 3 times the square root of 3. So there's two of those. So it'll be minus 6 times the square root of 3. Then all of that is divided by 9 minus 3. 9 minus 3 is 6. Now both terms in the numerator are both divisible by 6. So this becomes 2 minus the square root of 3. And that is our final answer. That's going to do it for this video, and I hope to see you in the next one.